Welcome back. In today's lesson, we are going to talk about complex number, and under this, we are going to look at what is meant by complex number, the powers of the imaginary unit, the addition, subtraction, division, and the conjugate of a complex number. And also, we are going to look at what is meant by equality of a complex number. The big question is, what is complex number? Complex number refers to a number that has a real part and an imaginary part. It is usually represented as this: Z is equals to A plus BI, where A is a real number. A is what? Real number. B is also a real number. And I is what? The imaginary unit. Imaginary unit. Let me complete this. Do you understand? This is how a typical complex number look like. We have A can be any real number and B can also be any real number, but I is an imaginary unit. Now, the meaning of I usually denoted as the square root of -1. If you punch this expression in your calculator, if you take your calculator and try this, take the square root of -1, you are going to realize that it's going to give you syntax error or math error. So in an attempt to solve questions that involve the root of a negative number, we bring in this word complex number. Are you getting it? So let's look at a typical example. What is the solution to this quadratic equation? X squared minus 1 is equals to 0. You can easily solve this by going like this: x squared equals to 1, then x is equals to plus or minus square root of 1. X is equals to plus 1 or minus 1. But what of in a situation whereby we are told to find the solution to this quadratic equation? X squared plus 1 is equals to 0. Now look, x squared is equals to minus 1. X squared, x is equals to the square root of plus or minus square root of -1. Now, if you punch this in your calculator, you cannot get the value of -1. The calculator will give you syntax error or math error. So in an attempt to solve this, we proceed as this: x is equals to, since we know that root of -1 is known as the imaginary unit, which is what? I. So I can proceed as this: x is equals to plus I or negative I. You understand? Where I is what? The root of -1. So don't forget that I told you that a complex number has two parts. Are you getting it? A complex number has two parts. The first part is the real part, and the second part is the imaginary part. Now let's look at this. We are given A plus BI. The real part is A. A is what? The real part. Real part. And B is what? The imaginary part. So now you can attempt this. Given that Z is equals to 3 plus 2I, you can see that what is the real part? When we are given this complex number, what is the real part? The real part is what? Real Z is what? 3. Then imaginary Z is what? 2. You understand? So let's take another example. When we are given that Z is equals to 4 minus 3I, the real part of this complex number is what? That will be real Z is what? 4. And the imaginary part is what? -3. You understand? Please, it is very important that you take note of the signs. Okay? It is very, very important that you take note of the signs. So now let us proceed. Let's look at the powers of imaginary units. Don't forget that the imaginary unit is represented as what? I. And I is what? The square root of -1. Now, when I is raised to the power of 2, that will be what? The square root of -1 raised to the power of 2. The square root of -1 raised to the power of 2 is what? -1. Because square root of -1 raised to the power of 2 can be written as what? -1 raised to the power of 1 over 2 multiplied by 2. That will be what? -1 raised to the power of 2 over 2, which is equals to what? -1. You understand? What if I is raised to the power of 3? That will be I raised to the power of 2 multiplied by I raised to the power of 1. Is that not it? You understand? Please, I want you to pay attention. According to the law of indices, if we have A raised to the power of B multiplied by A raised to the power of C, that will be what? A raised to the power of B plus C. So it's the same thing as this. If I multiply this, I'm going to have I raised to the power of 2 plus 1, which is what? I raised to the power of 3. Now let us proceed. Don't forget that I raised to the power of 2 is what? Minus 1. So I'm going to have minus 1 multiplied by I raised to the power of 1. Do you understand? I raised to the power of 2 is minus 1. So minus 1, which is I raised to the power of 2, multiplied by I. Multiplied by I raised to the power of 1. So don't forget that I raised to the power of 1 is I. So I is what? Root of minus 1. So I'm going to have minus the square root of minus 1. So this is also the same thing as what? Minus I. You understand? So what if I is raised to the power of 4? I raised to the power of 4. How do we do this? Don't forget that I raised to the power of 2 is what? Minus 1. So I can say I raised to the power of 2. I raised to the power of 2 raised to the power of 2. Do you understand? That is, by the time I open this bracket, I'm going to have I raised to the power of 4. And don't forget that I raised to the power of 2 is what? Minus 1. According to this, I raised to the power of 2 is minus 1. So I'm going to have minus 1 raised to the power of 2. Minus 1 multiplied by minus 1 is what? 1. So I raised to the power of 4 is what? 1. I raised to the power of 5. I raised to the power of 5 can be written as I raised to the power of 4 multiplied by I raised to the power of 1. Don't forget that I raised to the power of 1 is also the same thing as I. Are you getting it? I just want you to understand. That is why I'm putting this one, okay? So, and don't forget that I raised to the power of 4 is what? 1. So I'm going to have 1 multiplied by I raised to the power of 1. I raised to the power of 1 is what? I. And I is what? Root of minus 1. So 1 multiplied by I. Are you getting it? That is I. So I raised to the power of 5 is what? I. So that's how you are going to do. Let's proceed to I raised to the power of 6. I raised to the power of 6 can be expressed as I raised to the power of 5 multiplied by I. Don't forget that I raised to the power of 5 is what? I. So I'm going to have I multiplied by I. This is what? I raised to the power of 2. And I raised to the power of 2 is what? Minus 1. So for this, I'm going to have minus 1. Are you getting what I'm saying? So now you can do for I raised to the power of 7. I raised to the power of 7 is what? I raised to the power of 6 multiplied by I. So I raised to the power of 6 was minus 1. So I'm going to have minus 1 multiplied by I. And I is what? Root of minus 1. So I can just put it like this. Minus 1 multiplied by I. That is what? Minus I. So for this, I'm going to have minus I. So I raised to the power of 7 is what? Minus I, which is also the same thing as what? Minus root of minus 1. You understand? So you can do for I raised to the power of 8. I raised to the power of 8 can be expressed as I raised to the power of 7 multiplied by I. So I raised to the power of 7 is what? Minus I. This minus I multiplied by I. Minus I multiplied by I. That is what? Minus I squared. Minus I squared. So, and I know that I squared is what? I squared is what? Minus 1. Are you getting it? So I'm going to have minus into bracket minus 1. So minus multiplied by minus 1, that is what? Plus 1. So I raised to the power of 8 is what? 1. Do you understand? So that is how to take the powers of the imaginary unit. Now, can you attempt this? I raised to the power of, find the value of I raised to the power of 20. Can you attempt this? If you want to attempt this, don't forget that I raised to the power of 20 can be expressed as this. I raised to the power of 4 all into bracket 5. You understand? Do you understand what I did here? By the time I expand this, I'm going to have I raised to the power of 20. And I know that I raised to the power of 4 is what? 1. Please, are you paying attention? I raised to the power of 4 is 1. So for this, I'm going to have 1 raised to the power of 5. So this is what? 1 times 1 times 1 times 1 times 1. So this is also 1. So I raised to the power of 20 is what? 1. You can attempt this also. I raised to the power of, let me say, 12. In order to attempt it, don't forget that I raised to the power of 12 can be expressed as I raised to the power of 4 raised to the power of 3. Do you understand? By the time I expand this bracket, I'm going to have I raised to the power of 12. You understand? So, and don't forget that I raised to the power of 4 is what? 1. So, I'm going to have 1 raised to the power of 3. So, this is also 1. You understand? So, I don't know. You can try this. Can you find the value of I raised to the power of 100? Just try it at your own pace. Find the value of I raised to the power of 25. You can try this, okay? So, let us proceed to another concept known as the addition of complex number. Okay, let us attempt this question. Add 4 plus 5i plus 3 plus 3i. This is very simple. You just have to open the bracket and collect the like terms. Okay, so for this I'm going to have 4 plus 5i. This is not 51, no, this is 5i. Okay, plus 3 plus 2i. You understand? So collect like terms. You can see that this does not have an imaginary unit and this does not have an imaginary unit. So I'm going to have 4 plus 3 plus 5i plus 2i. You understand? So for this, I'm going to have 7 plus 7i. Do you understand? So, okay, let's attempt this. We just have to open the bracket and collect the like terms. Okay, so I'm going to have 4 plus 6i plus 3 minus I. You understand? So, since 4 and 3 does not have an imaginary unit I, so I'm going to have 4 plus 3 plus 6i minus I. So, 4 plus 3 is 7. So, this will be 7 plus 6i minus I. That is plus 5i. So, I'm going to have plus 5i. So, the addition of this complex number is 7 plus 5i. So, let's have one more example. 2 plus 3i plus 5 plus 4i plus 2 minus 5i. So now I told you that you just have to open the bracket and then collect like terms. So for this I'm going to have 2 plus 3i, then this additional sign, plus 5 plus 4i plus 2 minus 5i. So now we are going to collect like terms. Okay, so 2 does not have an imaginary unit. 2 plus 5 plus 2 plus 3i plus 4i minus, this should be minus because this sign minus 5i. Do you understand? So let us proceed. 2 plus 5 plus 2, that is 9. So for this I'm going to have 9 plus 3i plus 4i minus 5i. That will give us plus 2i. So for this, I'm going to have plus 2i. You understand? So the addition of this complex number is what? 9 plus 2i. Now let us look at subtraction of complex number. Let us evaluate this example 1. We have 4 plus 5i minus 3 plus 2i. I want you to take note of this sign. If you want to open this bracket, you have to put like this: 4 plus 5i, then you are going to use this minus sign to open this bracket. That is, you are going to multiply the entity in this bracket by the minus sign. Don't forget that this minus is also the same thing as what? Minus 1. You understand? There is an invisible 1 in this place. So, minus multiplied by 3, we are going to have minus 3, minus multiplied by plus 2i, we are going to have minus 2i. You understand? So, for this, I'm going to have 4 minus 3 plus 5i minus 2i. You understand? So 4 minus 3 is what? 1. 5i minus 2i, that is what? Plus 3i. So for this, I'm going to have plus 3i. So the subtraction of this from this is what? 1 plus 3i. Now let's look at example 2. We are told to evaluate 4 plus 7i minus 2 minus 5i. Okay, let's proceed. We have 4 plus 7i. We're going to use this minus to multiply all the entity in this bracket. Are you getting it? So I'm going to have minus multiplied by 2. So I'm going to have minus 2. Minus multiplied by minus 5i. So I'm going to have plus 5i. So after this, we are going to collect the like terms, Abby. So since 4 and minus 2 does not have an imaginary unit, so I'm going to have 4 minus 2 plus 7i plus 5i. You understand? So 4 minus 2 is what? 2. 7i plus 5i, that is 12i. So I'm going to have plus 12i. Okay, now let us evaluate this. For this, we are going to have 3 plus 5i. I'm going to use this minus to multiply all the entity in this bracket. So I'm going to have minus multiplied by 6, that is minus 6, minus multiplied by 2i, that is minus 2i. So I'm done with this. Let's proceed to the third bracket. So I'm going to have plus 8 minus 5i. After this, we are going to collect the like terms, okay? So I'm going to have 3 minus 6 plus 8 plus 5i minus 2i minus 5i. So 3 minus 6, that is what? Minus 3. Minus 3 plus 8, that is 5. So I'm going to have 5 plus 5i minus 2i, that is plus 3i. Plus 3i minus 5i, that is minus 2i. So I'm going to have minus 2i. So this evaluation is what? 5 minus 2i. Let us evaluate this. If z is equals to 6 plus 5i minus into bracket 4 minus 3i plus into bracket 2 minus 7i, find the real z and the imaginary z. In order to solve this question, we first have to evaluate the value of z. After then, we can now find the real part of z and the imaginary part of z. So let us proceed. Since z is equals to 6 plus 5i minus 4 minus 3i plus into bracket 2 minus 7i. So for this, I'm going to have, open the bracket, I'm going to have 6 plus 5i. Use this minus to multiply all the entity in this bracket. I'm going to have minus multiply 4, that is minus 4, minus multiply minus 3i, that is plus 3i, plus 2 minus 7i. So I have opened the bracket. The next step is that we are going to collect the like terms. So for this, I'm going to have 6 minus 4 plus 2 plus 5i plus 3i minus 7i. So we're going to have 6 minus 4, that is 2. 2 plus 2, that is 4. So for this, we're going to have 4. 5i plus 3i, that is 8i. 8i minus 7i, that is I. So this is going to be 4 plus I. So the real z is the real part of z. Now look at this complex number. What is the real part? Yeah, the real part is 4. So the real part of z is 4. So the imaginary part of z is what? I is 1. I get what I'm saying. You are not going to put the imaginary unit. I get what I'm saying. Because the coefficient of this imaginary unit is what? 1. 1i is also the same thing as what? I. So the imaginary part of this complex number is what? 1. The real part is what? 4. Are you getting what I'm saying? Now, let us attempt example 2. The first step is that before we can find the real part of z and the imaginary part of z, we first have to evaluate this, okay? So for this, I'm going to have z is equals to 3 plus 5i minus 5 minus 3i minus into bracket minus 2 minus 7i, okay? So now, let us open the bracket. I'm going to have 3 plus 5i minus multiply by 5 minus 5 minus multiply by minus 3i. So I'm going to have plus 3i minus multiply by minus 2. I'm going to have plus 2 minus multiply by minus 7i. So I'm going to have plus 7i. Okay? Now the next step is that we are going to collect the like terms. So I'm going to have 3 minus 5 minus 5 plus 2. So plus 5i plus 5i plus 3i plus 7i. So 3 minus 5, that is minus 2. 3 minus 5 minus 2. Minus 2 plus 2, this is 0. Are you paying attention? Let's proceed. 5i plus 3i. This is 8i. 8i plus 7i. That is 15i. So this will what? 15 plus 15i. So the evaluation of this is what? 0 plus 15i. Now, we cannot determine the real part of z. The real part of z is what? What's the real part among this complex number? The real part of z is what? 0. And the imaginary part is what? The imaginary part of z is what? 15. So we have determined the real part of z and the imaginary part of z. So when you are asked to find the real part of a complex number, that's how you are going to go about it. So let us proceed to the multiplication of complex number. From our basic algebra, when we are asked to multiply, let us assume that we have a plus b and another bracket a plus b. If we want to multiply this, how do we go about this? We first take the first element here, we multiply it, then we use it to multiply the other. Then we take the second to multiply each. Abi? So now the same rule is applicable in complex number. For this, we are going to have a multiplied by a, that is what? A squared, plus a multiplied by b, that is ab. Then the next one, we are going to use b multiplied by a, that is what? ab, plus b multiplied by b, that is b squared. You understand? So for this, we are going to have a squared plus 2ab plus b squared. You understand? So the same rule is also applied, is also applicable in complex number. Are you getting it? So now let us attempt these examples. We have example 1. Evaluate 4 plus 5i multiplied by 3 plus 2i. Okay, we are going to use the same approach that we use here. Okay, so now let us proceed. We are going to take this 4 multiplied by 3. 4 multiplied by 3. So I'm going to have 4 multiplied by 3. That is what? 12. Abi? So 4 will also multiply 2i. Are you getting it? So 4 multiplied by 2i. That is what? 8i. Are you paying attention? So we are going to use the second element. 5i multiplied by 15. 5i multiplied by, oh sorry, 5i multiplied by 3. sorry. 5i multiplied by 3. So I'm going to have 15i. Then 5i multiplied by 2i. 5i multiplied by 2i. So 5 multiplied by 2, that is what? 10. So I'm going to have 10. I multiplied by I, that is I squared. So I'm going to have 10i squared. Do you understand? So the reason why I wrote this is because I want you to understand, okay? If I'm solving this in the exam, I didn't have to put this, okay? So now let us proceed. So for this, I'm going to have 12. Let me bracket this so that you won't be confused. Okay, for this, I'm going to have 12 plus 8i plus 15i plus 10i squared. Do you understand? So 12 plus 8i plus 15i plus 10i squared. Let us proceed. 8i plus 15i, that will give us 23i. So I'm going to have 23i plus 10i squared. Okay, don't forget that from, you know that we have already done the powers of imaginary units. So I squared is also the same thing as what? Minus 1. So let us proceed. For this, I'm going to have 12 plus 23i plus 10 into bracket minus 1. Please, I want you to pay attention. For this, we are not having 10 minus 1. This is 10 multiplied by minus 1. Are you getting it? Where minus 1 is what? The value of I squared. Are you getting it? So now let us proceed. For this, I'm going to have 12 plus 23i plus into bracket 10 multiplied by minus 1. That is what? Minus 10. You understand? So let us proceed. I'm going to have 12 plus 23i plus multiply by minus. So I'm going to have minus. So for this, I'm going to have minus 10. You understand? So for left like terms, I'm going to have 12 minus 10 plus 23i. This is equals to 12 minus 10 is 2. So 2 plus 23i. You understand? So the evaluation of this is what? 2 plus 23i. Do you? Example 2. Evaluate 4 minus 5i multiplied by 2 plus 2i. We are still going to use the same approach, okay? So now let us proceed. For this, we are going to have 4 multiplied by 3. That is 4 multiplied by 3. 4 times 3, that is 12. 4 multiplied by 2i. 4 multiplied by 2i. This is what? 8i. So I'm going to take this and multiply it with the whole bracket. So for this, I'm going to have this minus 5i multiplied by 3. Minus 5i multiplied by 3. That is what? Minus 15i. So for this, I'm going to have minus 5i multiplied by 2i. Minus 5i multiplied by 2i. So minus 5 multiplied by 2, that is minus 10. I multiplied by I, that is I squared. And don't forget that I squared is what? Minus 1. So if I want to evaluate this, I'm going to go about this. I'm going to go like this. 12 plus 8i minus 15i minus 10i squared. You understand? However, I want you to pay attention here. While solving this in the exam, you didn't have to put all this arrow. I just want you to understand. That's the reason why I put all the arrows, okay? So you didn't have to put all this, okay? Just proceed and get this. Well, let's proceed. 12, 8i minus 15i, that is minus 7i, minus 10 into bracket minus 1, because I square is what? Minus 1. So for this, I'm going to have 12 minus 7i minus 10 multiplied by minus 1, that is plus 10. So I'm going to have plus 10. For that like terms, I'm going to have 12 plus 10 minus 7i. 12 plus 10 is what? 22. So 22 what? Minus 7i. So the evaluation of this is what? 22 minus 7i. So let's proceed to example 3. Evaluate 3 plus 4i multiplied by 2 minus 5i multiplied by 1 minus 2i. This is kind of complex, right? Just pay attention. The first step is that just first take the two parts. For this, I'm going to take this first part, okay? I'm going to take the product of this first two parts. I get what I'm saying. So I'm going to leave this out. So for this, I'm going to have 3 plus 4i multiplied by 2 minus 5i. You understand? So let's take the product of this, okay? Let's take it step by step. 3 multiplied by 2, that is 6. 3 multiplied by minus 5, that is minus 15i. Okay? So 4i multiplied by 2, that is plus 8i. 4i multiplied by minus 5i, that is minus 20i squared. You understand? So let's proceed. 15i minus 15i plus 8i, that is what? Minus 7i. So I'm going to have minus 7i minus 20i squared. Collect like that. Oh, wait. 6 minus 7i minus 20 into bracket. I square is what? Minus 1. So I'm going to have minus 1 here. For this, we're going to have 6 minus 7i minus 20 multiplied by minus 1. That is what? Plus 20. So for this, 26 minus 7i. Do you understand? So now, I have taken the product of these two complex numbers. This complex number A, complex number B, complex number C. I have taken the product of A and B. Are you getting it? Now, let us take the product of A, B, and C. So I'm going to take this 26 minus 7i multiplied by C. C is what? 1 minus 2i. You understand? Please, I want to pay attention. When you are told to multiply 3 complex number, first take the product of the first 2. Are you getting it? That's what I did. I take the product of the first 2, I got 26 minus 7i, then I multiply the product of the first 2 with the third complex number. Are you getting it? So let's proceed. 26 multiplied by 1, I'm going to have 26. 26 multiplied by minus 2i. that is what? Minus 52i. So minus 7i multiplied by 1, this also give minus 7i. Minus 7i, this is 7. Minus 7i multiplied by minus 2i, that is plus 14i squared. I squared. Do you understand? So now let us proceed. 26 minus 52i minus 7i. We are going to have minus 59i plus 14 into bracket minus 1. Do you understand? Because I square is what? Minus 1. So let's proceed. 26 minus 59i plus 14 multiplied by minus 1. That is what? Minus 14. Do you understand? So let's proceed. 26 minus 59i minus 14. If you collect like times, I'm going to have 26 minus 14 minus 59i. So 26 minus 14, that will give us 12. So I'm going to have 12 minus 59i. Do you understand? So 26 minus 14 is what? 12. So 12 minus 59i is the evaluation of this. Are you getting what I'm saying? By the time we multiply this complex number, this is what we're going to get. So this is the final answer. So I'm going to give you a question now. I want you to attempt it, okay? Evaluate 2 plus 5i multiplied by 3 minus 4i multiplied by 6 plus 7i. I want to evaluate this, okay? Now, let us proceed to the conjugate of complex number. Now, I want you to write this down. Conjugate complex number are pairs of complex number that are identical, but their middle sign is different. Are you getting it? Conjugate complex number are complex number that are identical, but their middle sign are different. Look at this. Let's assume that we are given this complex number. Z is equals to 3 plus 4i. Z1 is equals to 3 plus 4i. And Z2 is equals to 3 minus 4i. These pairs of complex number are conjugate complex number, because this is an example of conjugate complex number, because we have the Z1 is the same as Z2 except for the sign that is in the middle. So when we have this type of complex number, these are what we call the conjugate complex number. Now, if I give you this complex number, Z is equals to 4 plus 6i. What is the conjugate of Z? The conjugate of Z is what? Conjugate of Z is what? 4 minus 6i. Do you understand? So if you are given that Z is equals to 3 minus 2i, what is the conjugate of this? The conjugate of this complex number is what? The conjugate of this complex number is 3 plus 2i. Do you understand? So if you are given that Z is equals to 5 minus 6i, we are given that 5 minus 6i. What is the conjugate of 5 minus 6i? The conjugate of 5 minus 6i is what? 5 plus 6i. So when we have a pair of complex numbers that are identical, but their middle sign, that is the sign between this complex number, the middle of this, the first complex number, and the middle of the second number, and second complex number is different. Those pairs of complex number are known as what? Conjugate complex number. Are you getting it? So now, another thing that I want you to know about conjugate complex number is this. When we take the product of a pairs of conjugate complex number, the result is always equals to real number. Are you getting it? Now let's look at this. These are a pairs of conjugate complex number. Is that not it? Yes, it is. Now let us take the product of this complex number. That is, I'm going to have Z1 multiplied by Z2. That will be equals to what? 3 plus 4i multiplied by 3 minus 4i. You understand? So 3 multiplied by 3, I'm going to have 9. 3 multiplied by minus 4i, that is minus 12i. Plus 4i multiplied by 3, that is plus 12i. plus 4i multiplied by minus 4i, that is what? Minus 16i squared. You understand? So for this, I'm going to have 9 minus 12i plus 12i. What's the answer? This will cancel this. So I'm going to be left with 0. For this, I'm going to have 9 minus 16i squared. So don't forget that I squared is equal to what? Minus 1. Is that not it? Yes, it is. For this, I'm going to have 9 minus 16 into bracket minus 1. Minus 16 multiplied by minus 1. That will give us plus 16. For this, I'm going to have 9 plus 16. This is equal to what? 25. So, this is equal to 25. So, the product of any pairs of complex and any conjugate complex number is equal to what? Is always a real number. Because you can see that 25 is a real number. Is that not it? 25 is a real number. So, when you take the product of a pairs of conjugate complex number, the result, the product is always equal to what? A real number. Are you getting it? So that's another thing that I want you to know, okay? So now, if I give you a question like this, given that z is equal to 2, z is equal to 2 plus 3i, what must be multiplied to z such that we are going to get a real number? You can look at that question. Given that z is equals to 2 plus 3i. What must we multiply to z such that we are going to get a real number? What's the answer? We are going to multiply z by its conjugate. That's it. We are going to multiply z by its conjugate. The conjugate of z is what? The conjugate of z is what? 2 minus 3i. You understand? Are you getting it? You just have to change the signs that is in the middle. Are you getting it? To get the conjugate. Are you getting it? So you are going to, by the time you multiply this conjugate, by the time you multiply the conjugate of this by this, you are going to get a real number. Are you getting it? So that's another thing that I want you to know about the conjugate of complex number. So that's it. Let us proceed to division of complex number. Okay, let's have a typical example. Find the value of 6 plus 4i all over 3. It is easy to evaluate this. We just say 6 divided by 3 plus 4i divided by 3. In so doing, we are going to have 2 plus 1.33i. You understand? So what if we are given a typical question like this? Evaluate 3 plus 2i all over 4 plus I. How do we go about this question? You can see that the numerator is a complex number. However, in this place, the denominator and the numerator is a complex number. But here we have only the numerator is a complex number. The denominator is a real number, so we can easily operate this. But here we cannot use the same method. Now, what do we do if you want to calculate this? In order to evaluate this, we just have to multiply both the numerator and the denominator by the conjugate of the denominator. Are you getting it? In order to evaluate this, we have to multiply both the numerator and the denominator by the conjugate of the denominator. Don't forget that this is the denominator. 4 plus I is the denominator. But the conjugate of 4 plus I is what? The conjugate of 4 plus I is what? 4 minus I. You understand? So, the next step I'm going to do is that I'm going to multiply both the numerator by 4 minus I all over 4 minus I. You understand? Please, I want you to pay attention. Whenever you are asked to evaluate the division of a complex number, the first thing that you have to do is to multiply both the numerator and the denominator by the conjugate of the denominator. Are you getting it? So now, let us proceed. For this, I'm going to have 3 plus 2i, 4 minus I, all over 4 plus I, 4 minus I. You understand? Okay, let's proceed. 3 multiplied by 4, that is 12. 3 multiplied by minus I, that is minus 3i. Plus 2i multiplied by 4, that is plus 8i. Plus 2i multiplied by minus I, that is minus 2i squared. You understand? All over 4 multiplied by 4, that is 16. 4 multiplied by minus I, that is minus 4i. plus I multiplied by 4, that is plus 4I, plus I multiplied by minus I, that is minus I squared. You understand? Let's proceed. 12, okay, 12 minus 3I plus 8I, that is plus 5I, minus 2 into bracket minus 1, because I square is what? Minus 1. So all over 16 minus 4I plus 4I, this will give us 0. You understand? So for this, I'm going to have minus I squared, minus into bracket minus 1, because I squared is what? Minus 1. Now let us proceed. For this, I'm going to have 12 plus 5I plus 2, all over 16 plus 1. You understand? So let's proceed. Collect like times. 12 plus 2, that is 14. I'm going to have 14 plus 5I all over 17. Do you understand to this point? So 14 plus 5I divided by 17. This is equals to 14 all over 17 plus 5I all over 17. 14 divided by 17, that is 0.82. 0.82 plus 5 divided by 17, that is 0.29. 0.29I. So the division of this complex number, that is 3 plus 2I all over 4 plus I, is what? 0.82 plus 0.29I. You understand? So that is how to evaluate the division of a complex number. Let us proceed to example 2. Evaluate 4 minus 5I all over 1 minus 2I. Don't forget that I told you that the first step is that we are going to multiply both the numerator and the denominator by the conjugate of the denominator. Now, the denominator is what? 1 minus 2I. The conjugate of 1 minus 2I is what? 1 plus 2I. So I'm going to have 4 minus 5I all over 1 minus 2I multiplied by 1 plus 2I all over 1 plus 2I. You understand? So let us proceed. We are going to have 4 minus 5I 1 plus 2I all over 1 minus 2I 1 plus 2I. So let us open the bracket. Multiply 4 multiplied by 1, that is 4. 4 multiplied by 2I, that is plus 8I. Minus 5I multiplied by 1, that is minus 5I. Minus 5I multiplied by plus 2I, that is minus 10I squared. All over 1 multiplied by 1, that is 1. Minus 2I, 1 multiplied by 1, that is 1. 1 multiplied by plus 2I, that is plus 2I. Minus 2I multiplied by 1, that is minus 2I. Minus 2I multiplied by plus 2I, that is minus 4I squared. Do you understand? So now, collect like terms. This will be 4 plus 3I plus 10. Because minus 10 multiplied by minus 1, that is what? Plus 10. All over 1 minus 4 multiplied by minus 1, that is plus 4. So I'm going to have 4 plus 3I plus 10, that is 14. 14 plus 3I all over 5. So this can be written as 14 over 5 plus 3I over 5. 14 divided by 5, that is 2.8. 2.8 plus 3I divided by 5, that is 0.6. 0.6I. So the division of the complex number 4 minus 5 all over 1 minus 2I is 2.8 plus 0.6. I want you to attempt this. Evaluate 3 plus 2I divided by 1 minus 3I. If you get your answer correctly, you are going to get minus 0.3 plus 1.1I. That's the answer. Minus 0.3 plus 1.1I. If you follow the same procedure that I use, you are going to get that as your answer. You understand? So I want you to attempt that. Now let us proceed to equality of a complex number. Are you getting? two complex numbers are said to be equal if the two real parts are equal and if the two imaginary parts are equal. Let's assume that we are given complex number z1 is equals to a plus di, and we are given another one, complex number z2 is equals to b plus ci. We can say that these complex numbers are equal if z1 and z2 is equal. Z1 is equals to z2. If a is equals to b, you know that a is what? The real part of this complex number, and b is the real part of the complex number z2. So if a is equals to b and di is equals to what? Ci, then we can say that these two complex numbers are equal. Now let's look at this example. Given that z1 and z2 are equal, if z1 is equals to x plus yi and z2 is equals to 6 plus 8i, find the value of x and y. Now, if you want to solve this question, don't forget the laws of equality of complex number. Two complex numbers are said to be equal if the two real parts, that is the real part of this complex number and the real part of this complex number are equal, and the imaginary parts are also what? Equal. Okay, so if z1 is equals to z2, so the real part will also be equal. Therefore, x is equals to what? 6, and y is equals to what? 8. You understand? So this is the correct answer. You understand? So, okay, example 2. If a plus b plus a minus bi is equals to 7 plus 2i, find the value of a and b. Don't forget that for two complex numbers to be equal, the real part of the two complex numbers must be equal and the imaginary part of the two complex numbers must be equal. So this is the real part because we didn't have any imaginary unit here. So the real part of this complex number is what? A plus b. And since for this law to take place, a plus b must be equals to what? The real part of this complex number also. So I'm going to equate a plus b is equals to what? 7. Do you understand? The real part of this complex number must be equals to the real part of this complex number. And the real part is what? A plus b. The real part of this complex number is what? 7. So I equate a plus b equals to what? 7. Now, let's go to the imaginary part. The imaginary part is the what? A minus b. So a minus b must be equals to what? 2. You understand? So now, in order to determine the value of a and b, we are going to solve this equation simultaneously. You understand? In order to solve this simultaneously, just add both equation 1, call this equation 1, and call this equation 2. Now, add both equation 1. We are going to have 2a is equals to what? 9. Because plus b minus b, that is what? 0. A plus a is 2a. 7 plus 2 is what? 9. So, a is equals to 9 divided by 2, that is 4.5. So, a is 4.5. In order to determine b, substitute a into any of this equation. We are going to have 4.5 plus b is equals to 7. So b is equals to 7 minus 4.5. So b is equals to what? 2.5. Do you understand? So a is what? 4.5 and b is what? 2.5. So that is the value of a and b. We've come to the end of today's class. See you in the next class.